Hello everyone, my name is Doreen Mlote. I'm from Tanzania, a country in East Africa, and I am a civil engineer and currently a PhD student here in Singapore. So today I want to take you to the construction sector. So when we talk about sustainability, we always forget talking about construction sector. But today I want us to talk about adaptability and flexibility of building designs, materials, and processes in the construction sector as a strategy towards sustainable construction. So we are experiencing a lot of effects in the global climate change. We have seen a lot of places, wildfire is being reported, but also lands are sinking, there's rise in sea levels. We're also seeing the scorching heat even here in Singapore, but also we see heavy rains and floods in various parts of the world. And all this are caused by the greenhouse gas emissions that are emitted into the atmosphere due to various human activities. But when we look at the construction sector, we see that construction contributes about 50% of the total greenhouse gases. And among that, 11% is actually attributed by the embodied carbon. And this is the one that is associated by the materials that we use in the building designs, but also the designs themselves and the processes that are associated in the construction. So I want you to imagine a 1 meter cube of concrete. So it's just about of this size. So 1 meter cube of concrete is about 430 kilogram carbon dioxide equivalent of embodied carbon. Now globally, we produce about 14 billion meter cube of concrete. And this is equivalent to about 6 trillion embodied carbon every year. So we can see the amount of impact that we are creating from the construction sector, and we really need to do something about it. So the construction sector produces embodied carbon in various stages, from the beginning where we extract the raw materials to the end where the building's life ends, and then we demolish the building and actually dispose the materials as waste or try to reuse the materials. So during all these processes, there is embodied carbon that is being emitted to the atmosphere. So when we talk about sustainability in the construction sector, we have to break it down into 3 main parts. And that is first looking at the materials, the designs, but also the processes. So when we talk about the materials, I was particularly interested in timber as a renewable material. Why timber? Because timber has sequestration properties, which enables it to store carbon for a longer time and prevent it to being emitted to the atmosphere. So previously, I worked in a project where I tried to reinforce timber with carbon fibers in order to enhance the mechanical performance of timber. Timber, as we know, is a very weak material compared to concrete and other conventional materials like steel. That's why it's losing confidence in many designers when it comes to what to use in construction. But by reinforcing it with carbon fibers, we are trying to ensure that we can increase that confidence that timber can perform equally or even better than concrete and other materials. So in this experiment, we found out that almost the 80% of load-bearing capacity was increased additionally compared to the unreinforced case of timber beams due to the reinforcement of carbon fibers. But we also found out something interesting known as pseudoductility, and this is the ability of timber to behave like a metal. So the timber took longer time to break after it was reinforced with carbon fibers. But we also noticed that there is an optimum amount of carbon fibers that is supposed to be used, because as you keep on reinforcing with extra carbon fibers, it actually turned back to brittleness after some time. So this project was very impressive. We were also able to use these research results to apply it in recycling wooden planks from a mall here in Singapore and created a bench which is currently in use. And we also think of various materials that are also promoting sustainability in the construction sector. So we also have concretine, which is the combination of concrete and graphene, where graphene improves the concrete strength by more than 2 times and also reduces the permeability more than 4 times. But also we have bendable concrete, we have bamboo, we have mycelium, and all 3D printed concrete as well, which are emerging materials when it comes to sustainable construction. So although we talk about materials, we also have to talk about the designs that we create. And here is when we really start to think, how are we designing the building itself? We have to think if we want it to be disassembled easily so we can reuse the components of the building, or we want the building to be adaptable in the future. So the first way, we always think about prefabrication. So prefabrication allows us first to reiterate the same designs and create a design that can be iterated easily in the construction site. But also, design for disassembly allows us to disassemble the components in the future and reuse them as different parts in a different building. We also have regenerative designs. Most of you, if you have visited Singapore, you will notice that there is a lot of greenery in the building itself. And what this means is the gross floor area that is accommodated by a building has to be replaced in the building using the greenery area. So we are trying to do this in order to make sure that although we are expanding and growing as a city, we should not forget to preserve our environment and preserve the greenery of the city. So the next step is design for adaptability. So we can see that most of the times we design buildings and maybe they are very durable and they can stand for 90 years, but somehow we demolish them even within 5 years or 10 years. Why is it so? Because there are changes in needs, there are changes in occupancy needs, and it may force us to demolish the building earlier in order to create something that has more value of use of that land. So a design for adaptability is a process to allow us to actually accommodate these future changes in the future. So we are trying to reuse the whole building, to repurpose the entire building without the need of major renovations or major reconstructions. So design for adaptability breaks the linear flow of materials in construction and instead allows us to reuse, repurpose, or relocate materials and create a circular flow of materials. So I'm going to talk about a case study in Sydney, Australia, and this is the Key Quarter Tower, which was initially built in 1976 and adaptively repurposed in 2022. So this tower was actually sitting in the Bay Area, but it had blocked views, and the owner of the tower initially wanted it demolished so that they can create a new structure to have better value of the area. But the architects and engineers advised him, why don't we try to use adaptability in this building? So we can see that instead of demolishing the entire building, they demolished only a part of the building. They were able to retain a major part of the building and additionally increase a new structure which was able to sustain and actually improve the impact of the building. So what did this do? The new Key Quarter Tower has 65% of the original tower retained, and by this they were able to save 7.3 million kilograms of embodied carbon, which is equivalent to 35,000 flights from Melbourne to Sydney. But also, they had a bonus where they increased the surface area of the building by 2 times the initial area, and because of this, they were able to increase the building life by extra 50 years. The final thing is the processes. We have to think about how we go on with the processes in the construction sector. So we have to make sure that we are building in layers. So we don't think of the building as just one big structure, but as layers of different structures and components in the building, which can be refurbished or they can be maintained in different times and in different period of years. We also have to track our embodied carbon. We have to keep track of the materials that we put in the building, which I'll talk about in a few minutes. So the first thing is material passports, and what this means is we have to actually understand what exactly goes into the building, but also we have to document it in order that future engineers, future designers can use this information and see if they can reuse these components in the future. So we have a platform that is very interesting software. It's called Madaster, and this Madaster software is publicly open to most people. So you can use this to actually store the information of all the materials of your building, and because of this software, you can actually make sure that 90% of your building is actually being reused in the future. We also have to track the life cycle of materials from the beginning of the materials as raw materials, we call it from cradle, but also to the end of the materials where it's actually being disposed, and that's the gate, but also going back to being reused or repurposed, so from cradle to cradle. A sample embodied carbon report looks like this. It also gives a various amount of embodied carbon that is being emitted, but also the impact that is going to be associated with that emission. So for example, instead of only saying 378 kilograms of embodied carbon that most people won't understand, you can say it's the same as flying 715 times or buying 429 cars, which is something that people can actually relate to. We also have in Singapore a new embodied carbon calculator, which is open access in beta stage, which is called the carboncalculator.sg. And it's actually a very interesting platform where you can track your embodied carbon, track all the freight of construction materials, and see how much embodied carbon impact you're creating by this building design. Finally, we have to utilize more than one effort. We cannot only do one effort and expect it to have the optimum and maximum results. We always have to integrate maximum, making sure that the materials we're using are sustainable, the designs you're creating are sustainable, but also the processes we are following during the construction are also sustainable. In my research going forward, I'm going to focus on design of adaptability of building designs, but also making sure that although we are trying to focus on sustainability, we are not forgetting that the building has to be integral. The structural integrity of the building is still important. The safety of the building is still important. So how can we get the sustainability effect, but still not compromise the structural integrity of the building itself? And also trying to making sure that the efficiency of the design processes and the construction processes is taken into account during the designs. Finally, design for adaptability is not just an opportunity, it's a necessity. It helps us to really balance between material use and resource optimization in order for us to preserve the environment to the maximum level. Thank you.